and OLAP is used for analytics use case.
Okay, yeah, that's right. Any further details?
Yeah, I don't remember properly, but yeah, OLTP are optimized for inserts and updates, and OLAP are more for aggregation queries select.
Yeah, right. Okay, good. So yeah, this is also one of the introductory question that comes. Generally, they will ask what is OLTP and what is OLAP. Okay, so OLTP, general OLTP, online transaction processing. OLTP means online transaction processing. I mean, we should not tell acronyms or abbreviations wrong. Then we will get wrong impression. They will think that we don't know. So OLAP means online analytical processing. So one is online transaction processing, and OLAP is for online analytical processing. Okay. So I will tell you what is this transaction processing and what is this analytical processing. OLTP and OLTP. So till now I said something. There are different examples that I told, like railway reservation, SBI, like bank deposits and withdrawals. So and ATM withdrawals, all these things. So they are point of sale, means where the end user transactions are happening. Okay, so when you ATM will work 24/7. Okay, bank may have some limited hours during daytime, but ATM 24/7, even midnight, 1 o'clock you go also. Of course, you can withdraw money and your record will be tracked. How much amount you withdrawn and what is the remaining balance and all. Okay, so and similarly on the website, you can browse anytime. On the website also, you can buy anything online and all. So your amount will be debited and that amount will be credited to that merchant. Everything will happen without any problem. So actually the source systems are actually called OLTP systems. Okay, the source systems means MySQL, okay, the RDS Postgres, okay, so SQL Server. These are all called actually OLTP databases. OLTP databases means they are not ideal for analytical processing. Analytical processing means actually data warehouse systems are called analytical processing. Okay, so OLTP systems means the databases, which are generally used as a backend for you see web applications like MySQL, SQL Server, Postgres, RDS. So these are all OLTP systems. Actually, means they will generally most widely used OLTP system is MySQL, or of course they can also use as some flat files. Okay, so what they will do is they will be available all the time, 24 hours. Any transaction happens anytime, they will capture. Okay, for example, I will write examples. MySQL, Postgres, RDS. Of course, Oracle also many customers will use as OLTP system, but Oracle has many versions and flavors. Okay, Oracle data warehouse is there. So yeah, so Oracle also will be used as a OLTP system. MySQL, of course, SQL Server. All these things can be used as OLTP. Of course, Oracle has Oracle Data Warehouse, and SQL Server also with high configuration sometimes will be used as I mean, not much used. Yeah, it is an OLTP system. But online OLAP systems are dedicatedly used for OLAP system. OLAP system means actually they are called actually data warehouses. Okay, so or on-premises data warehouses. Teradata, Oracle Data Warehouse. Okay, so yeah, these are the two leading data warehouses on premises, and of course, all cloud data warehouses. Redshift, Azure, Microsoft Azure, Google BigQuery, Snowflake. So yeah, I think these are the main. Yeah, in fact, these are the only data warehouses available for in the data warehouse industry. So AWS Redshift, Microsoft Azure, Google BigQuery, Snowflake. And on-premises data, the larger data warehouse on-premises, Teradata and Oracle Data Warehouse. Of course, sometimes SQL Server, but that's not that much major. Okay, so that's not used for OLAP system. I mean that much. These are the 95% of the market is used by Teradata and Oracle. Why 95? It's more than that, 98. Okay, so when cloud came into the market, these are the leading data warehouses on the cloud: Redshift, Microsoft Azure, Google BigQuery, and Snowflake. I mean, don't confuse with Snowflake as the. I mean, generally we discuss star schema and Snowflake schema, right? So don't think that this is a Snowflake. That Snowflake we discussed is a data warehouse design. Okay, I mean, generally people will get confused. Snowflake means, I think, on the data warehouse design that we discussed, the star schema and Snowflake schema. This is not that Snowflake. This is a cloud data warehouse like Redshift. Okay, this is one of the data warehouse, Snowflake. So yeah, so generally he will ask, do you know? I mean, based on the context that interviewer is asking. For example, he was asking, can you tell the difference between OLAP and OLTP? Okay, okay. Then he was asking about SCDs. Then he asked, what is star? Then what is Snowflake? Then you should tell about Snowflake. That's Snowflake, the data warehouse design. But if he's asking about, can you please tell me which is better, you think, or Redshift or Snowflake? Or can you please tell me why should I choose Redshift? Or there are many things like Snowflake and Azure, or at least do you know Snowflake? So based on the context, what he is asking, you should say Snowflake as a cloud data warehouse. If he is asking about SCD type 1, type 2, type 3, there, and if he's talking about facts and dimensions, and if he's talking about star schema, there Snowflake means it's a Snowflake design. Fact table surrounded by normalized dimension tables. That's Snowflake. Okay, cool. So here OLTP versus OLAP means, OLTP means initially all the databases, I mean, they are very less in storage capacity, right? Even Oracle, SQL Server, MySQL, these are all there since long time in the world. So they are basically OLTP systems. after you see as the data progresses, customers like companies like Oracle, they evolved into warehouse. Okay, and of course, throughout the world, it has many customers because it's keep on innovating and scaling with respect to storage and processing speed. So yeah, it is serving the purpose of data warehouse. But yeah, the things like MySQL, Postgres, RDS, SQL Server, they're almost still at the ODS means, yeah, I'll tell you what is ODS. Operational data store. Yeah, so in OLAP we call it as a data warehouse, right? So similarly in OLTP, yeah, we call it as operational data store. Means they are not data warehouses, but they will store the data that is called operational data store. Okay, all the transactional data, for example, during the ATM transactions, all the data will be stored, right? Till at the end of the day, they are loaded into data warehouse. I said in the warehouse, we generally load at the end of the night, right? All the transactions that took place. So where is that they are stored till the night, till end of the day? That place is called operational data store, ODS. Okay, so all the, for example, railway reservation transaction, they will be loaded at the end of the day. So where is that they stored? Yeah, of course, they are stored in the OLTP databases like MySQL, Postgres, RDS. So actually, that is only called operational data store. Okay, so yeah, the MySQL, Postgres, RDS, Oracle SQL Server, they will store the data till end of the day, and then all the data will be extracted, transformed, and loaded into OLTP databases. Okay, that is data warehouses. For example, see, I will show. See, in this diagram, we said, right, data warehouse source. You see here, these are all sources. That means MySQL. It's a OLTP, online transaction processing. I said MySQL, Oracle, or SQL Server, or Postgres. All these sources will come here. So they will store the data. Okay, these are called ODS, operational data store. They will store all the transactions. Then what we do, all the software engineers, they develop pipelines to extract. You see, extract, and here all the cleaning and the transformation will happen here, and then they will load it using, during the load only we'll implement SCA type 1, type 2, type 3, and load it into OLAP system. These data warehouse, target data warehouses are called OLAP, online analytical transaction processing. These are all data warehouses like Redshift, Redshift, Microsoft Azure, Google BigQuery, Snowflake. These are all data warehouses. So these are all OLAP. Okay, data warehouse systems are OLAP, online analytical processing systems. Analytical means for analytical purpose. I'll tell you what is analytical purpose. Analytical means reporting purpose. That's what analytical means, reporting purpose. Why are we loading into data warehouse? To generate reports only. That's why the technical term is analytical. Okay, online analytical processing. So all the data warehouses are OLAP, online analytical processing systems. Okay, these are all OLTP, online transaction processing systems. All the transactions means everything that we do at the sale counter, every withdrawal or every deposit or every ticket book, every ticket cancellation. Okay, or if you, in case of supermarket, every sale. Okay, every customer you will go and buy, right? So all those will be captured here. OLTP transactions are happening. OLTP systems. So generally they will use, most of the things will use MySQL or Postgres, or of course Oracle, or even MySQL or SQL Server. These things they will use. Okay, so since they are used for transactions, so they are called online transaction processing systems. And since the right side, the target data warehouse are used for analytical purpose. Analytical means reporting purpose. So they are called online analytical processing systems. And analytical means they are used for reporting. Obviously, see, in analytical purpose, in analytical side, data warehouse means what? All the properties of data warehouse will apply. Means they should be capable of storing the huge volumes of data. Yes. OLTP means they will store huge volumes of data, and in OLTP means, I mean, they generally store, one day, because at the end of the day we will load the data and again new data will come tomorrow. You understand here? In for example, you see ATM transactions, all the days transaction will be loaded at the end of the day. So here we don't maintain history and all for 5 years, 10 years. We may hardly maintain maybe for 3 days or 1 week, just in case if some file processing failed at the target end, we may need to resend the file for processing. So it may store maybe some 3 days history or 1 week history, but it's not going to store like months or years of history here. All the transactions will be captured here, no history will be maintained. Okay, so no reporting will be done here, they are only for transaction processing. But at the target end means OLAP end, yes, the data will be, I mean, history will be maintained even 10 years, 15 years, 20 years, 30 years, and it is used for reporting purpose. Okay, so yeah, it is used for reporting purpose. So yeah, and it requires huge storage because we are storing long history. So definitely it requires huge storage. And here you see data OLTP system, it should be 24 hours available. 24 hours available. Why? Because customer may do ATM transaction or anything anytime, or he may buy anything online, so from the internet. So it should be available 24 hours. Okay, practically zero downtime. But data warehousing, of course, generally we load the data into warehouse, right? So after loading, when users are consuming the data warehouse, I mean, generally the reports will be generated and sent to the top level management. So when those reports are running, it can be available. Otherwise it can be, of course, no problem, it can have some downtime. Means basically whenever users are accessing the warehouse, then it should be available. When users are not, for example, generally all the things that we are generating will be consumed by the US users, and US users will generally come at their time, morning, maybe 5 o'clock or 6 o'clock or 8 o'clock. So at that time, if the data warehouse is available, that's fine. Remaining time, even if it is down for some time, no problem, because it's not impacting the users. Okay, yeah, so because we know when the users will come and access the system, so at that time if you are available, that's fine. So at the OLTP side, OLTP means the data warehouse end, so some downtime, even there is some downtime, that is fine, no issues. But in OLTP, we don't know when users are going to do some ATM withdrawal at the night. We don't know, because you see throughout the India there are so many ATMs. We should know, no one knows which ATM, which customer will be going to do some transaction. Generally people will go to midnight shows and all, try to withdraw money. I mean, we cannot expect, sometimes they may go to some bar and all and come for money, we don't know. And sometimes people will sit at the home and try to do some transaction at the midnight. Okay, those transactions should be captured, so it should be available all the time, because we don't actually when the people will do this transaction. So in fact all the OLTP systems are available all the time, 24 hours, 24/7. So yeah, these are the differences we should be telling when we are asking about OLTP and OLAP. First we should tell like this: OLTP, online transaction processing; OLAP, online analytical processing. Okay, so OLTP systems will be available at the point of sale counters. Okay, OLAP systems are actually the data warehouses which are used for reporting purpose, or yeah, our users are top level management. Okay, here the users are the clerk kind of thing, clerk, all the end users, these people are like all the customers basically. But the users of OLAP systems are top level management generally. Okay, the executives and senior executives and VPs of the people who will be reading those reports to make some decisions. And it here 24/7 availability is required, but here even some downtime also no problem when the users are not accessing the data warehouse. Okay, so that's fine. So here only a few, I mean, generally 1 day or a few days history will be maintained. But here we can maintain even a few years, 10 years, 20 years, 30 years history also will be maintained because it is for analytical purpose. Okay, so yeah, it is completely transactional, but it is it's not transactional, it is summary. Okay, it is summary. Summary means aggregate level. Okay, here you see, here everything will be in detail actually generated and stored. That is called transactional. But here we don't store at the transaction level. We store at the aggregate level. Means it can be like daily what is the sales, or daily what is the quantity sold, or daily sales amount, or average amount, or monthly, weekly. In that aggregate level, we store the data at the target end. Okay, so yeah. So here only a few days history will be maintained. Here a long history, even for 10, 20, 30 years history will be maintained. Okay, yeah. So yeah, these are the major differences. Remaining all are not such a major differences. Yeah, people will say that here, for example, I will show. Yeah, so many difference will be there, but those are all useless differences. Okay, but whatever I said, they are the main. In fact, that's what a real-time working employee should be saying in the interview. Okay, yeah, but this is for your information. Yeah, OLTP, OLAP. OLTP means is here, right? Transaction processing, analytical processing. Users, clerk, IT professional means bank people, or yeah, the person who is doing the customer and transaction. Here it's knowledge worker, day-to-day operations, decision support, application oriented, certificate oriented, current, up to date. This is historical and summary. This is repetitive, ad hoc, read, write, simple, complex query, tens, yeah, number of records. Yeah, number of records. Yeah, at the OLTP system, general OLTP means what? Daily, for example, take ATM transactions, maybe some 100 million. Let's say you take 100 million throughout the world. If 1 day I'm on 100 million, there should be thousands of millions at the reporting end, because their history will be maintained. Yeah, that's what. Because here, if 1 day is 100 million, it is storing 10 years, 20 years, 30 years. That how many? It will be much more. So that's why it is. If you see, if 1 day is only some 100 or 10, then it stores the history, so it will be much more than this. That's what number of records. Here 10 means here millions, or here a few means here it's more, or here only millions means here it will be billion, like that. So, and you see that is number of records. Users will be 1000 here, 100. You see here number of users means generally who are the users of the OLTP systems. Generally all the customers, all the people of the world, or all the people of India, they are the users. Okay, anybody can go to railway reservation, anybody can go to bank, anybody can go to supermarket. So they are the users here. But here you see it's only hundreds. Here 1000, 100 means who are the users of the your data warehouse? Only the top level people are the business users. Means they are very few. Okay, so they are the people. Generally, the bank people or the business who is owning SBI people. Okay, they will analyze their data warehouse. That to their top level management, their senior executives. So they are very few in number. So they are the users of their data warehouse, OLAP. But here OLTP, all the people of the world who are the customers of SBI. In OLAP, only SBI authorized people who are authorized. I mean, generally the top level management who will be analyzing the reports, what's going on with the business. So they are very few. And yeah, data in size. So obviously OLTP systems, I mean, daily data will be gathered, so it will be a few MBs or GBs. But in OLAP side, you will have history stored, so it will be in gigabytes and terabytes. So transaction and its query throughput. Yeah, here, I mean, generally it's transactions, like more number of transactions like that we'll measure this. Okay, so but in OLAP, we see with respect to query, how fast the query is running or how much data query is processing. We'll talk in that way. Okay, so here that means how much time the transaction is taking, like that we will see. Because at the ATM and we cannot wait so much time. Hey, why it's taking this much time, like that we'll say. So here transaction processing or transaction throughput is important. Means it should be processed faster. Here query throughput is important. Means when we are running a report which need to be sent to the top level management, when everything that we write in a data warehouse is a report actually, which will be used for analyzing what's going on with the business. So there the query response should be important. Means query should run faster. Let's say in data warehousing, performance optimization is very, very important, because if you write a query, if it runs for 2 hours, it's of no use. If it can run in 2 minutes, then it's super. So yeah, query throughput or query response is important in OLAP side, but here transaction processing or transaction speed is important. Yeah, but yeah, finally it's talking about the same thing that we said. Okay, so but at the different angles. Okay, with respect to storage, with respect to users, okay, with respect to number of records, with respect to speed and all. But the main points that I said you should say, even you cannot tell all these things. Okay, OLTP online transaction, OLTP online analytical. Okay, OLTP is at the source end. Okay, OLTP is at the data warehouse or end users and top level management are the executives for OLAP, whereas the end users or customers are the users of this OLTP. So more users at OLTP, so less number of users in OLAP. Okay, less number of records in OLTP, and generally summary data will be there at the OLAP. Okay, OLAP is for reporting purpose. OLTP is only transactional oriented. Yeah. Once you understood what is OLTP and what is OLAP, you can tell in your own words. You don't need to mug up or by heart anything. I mean, generally, I never mug up anything. Okay, I will just think whatever comes to the mind. I'll just tell in the interview. So yeah, in OLTP you'll have less number of records, like thousands, and in OLAP you can have millions and billions of records. In OLAP you will have history of data like 10 years, 20 years, 30 years. In OLTP you will hardly have 3 days or 5 days history. So yeah, like that. Why we will maintain that 3 days or 5 days? Just in case if you lose data in OLAP while processing, while processing sometimes files will be lost or corrupted. So there may be need for resending the data to reprocess. So for that purpose, they will maintain maybe 3 days, 5 days, or 1 week data as a history. So that in case if required, it need to be sent to reload into a table or data warehouse again. So clear?
In OLTP DML operations, sir, select, update, delete. Like
Yeah, right. I mean, you see, in nothing like that. There also, but generally, we say select. In OLAP, we call select. For example, you see select. Generally, yeah. Here we
in
call
OLAP
select,
only DML operations,
because
select operation.
yeah, we call like DMLs. Like insert, update, delete. Yeah, generally because when a new customer comes, he will either update, deposit money, that is insert, withdraw money, it will be updated. Sometimes only completely withdrawal or closing the account to delete. So these things. But yeah, you got it right. Even railway reservation, booking a new reservation, insert. Okay, so sometimes we book the ticket for 5 people. Later on, we exclude 1 or 2%. Right? Ticket we book for 5 people, and later on we'll cancel for 1 person. and we'll only reserve for 4 people. That is update and delete. Okay, or completely cancel if you don't want. Yeah, that is insert, update, delete at the OLTP system. Yeah, generally OLAP means, yeah, we select the data because what we are doing here is all the thing that is to do with reporting. Reporting means select. Yeah, yeah. So yeah, this is one of the important point. Maybe you Google it here from your end.
Sir?
You Googled it, or how you got that point?
Google, sir.
Yeah, that's fine. Okay, so the better you use Google, the better you become knowledgeable. I mean, anyone. Okay, so that's why in the first class itself I said, don't just follow me blindly. Yeah, following me will help you, but you cannot become the top person just with my own knowledge. Just because in the class we'll miss some points. Okay, I mean, generally we miss some points. So whatever I miss, you will get in the net also. So always, that's what I said, for any concept that SCD types, Snowflake, any concept that I say, you always study from net, but make sure you know what I said. That is compulsory. On top of it, you just improve. Okay, because sometimes in the interview, you may not repeat what I said, but generally what you studied on the net can be, I mean, you may remember and you may tell. That is also good. Like this point, that insert, update, delete. Okay, yeah. Okay, that is also one of the valid point. Yeah, you may not remember some other point like OLAP is for history and OLTP is for maybe a few days. You may not remember that point, but you may remember. So somehow you need to add and present some couple of points in the interview. That is the funda. Okay, he should know that yes, this person is able to tell. Okay, rather than mug up. So like that. Yeah, okay, good. So can you proceed to next?
Yes.
Okay,
Yes, sir.
okay, cool. So once that is done, the next thing will be Redshift architecture. So yeah, so from generally before starting with Redshift, they will, I mean, generally they tend to ask, can you please tell me like what is Redshift architecture? Yeah, so I will tell you what is this architecture. Okay, so before going to Redshift architecture, we should know what is Redshift. Okay, so Redshift is a petabyte scale. What is that? Petabyte scale columnar cloud data warehouse. What is a Redshift? Redshift is a petabyte scale columnar cloud data warehouse. Petabyte scale columnar cloud data warehouse. Okay, cool. Why these three terms are used? So yeah, cloud data warehouse. It says that yes, it's a data warehouse, but it's data warehouse in the cloud. That's what it means. Okay. Redshift is a petabyte scale. I mean, till now I have used many times the Teradata and all. Why they named it as Teradata? Actually, Teradata ruled the market so well. Okay, it ruled the market for 30 years. Okay, so there is no competition for Teradata before cloud comes. Okay, so it was so fast, but it's on premise, and it can store. I mean, earlier, Oracle was famous, but Oracle can store up to some hundreds of gigabytes, GBs. But data is increasing rapidly. Okay, it is crossing even terabytes of data. After GB, TB means 1000 GB is 1 TB. So when data is increasing rapidly to terabytes, then this Teradata came into market and it took over all the market. Every people from Oracle, they are migrating to Teradata, and Teradata reports. Reports means OLAP. Okay, reports are running so faster, but it also comes with cost. People has to pay a lot of money, so that's where the cloud came, and it will reduce the cost. So similarly, what people will do, especially these small size customers, because they're easy to migrate, so they will tend to migrate to cloud because it's coming with low cost. Okay, so that's why they mentioned as petabyte. Petabyte means teradata. Of course, teradata can store also petabytes. Okay, so but at that time they named it as a tera. So tera, because at that time teradata was their goal. I mean, terabytes of data is their goal. So they mentioned it as a teradata. Okay, so thousands of GBs means 1000 GB is 1 TB. So many hundreds of terabytes, even to thousands of terabytes it can store. Thousands of terabytes means peta. So, but now they came latest, right? So Redshift came latest, so they know that data is crossing terabytes. So they named it this word, petabyte. Thousands of TBs are called petabytes. So they mentioned it in the definition itself. Redshift is a petabyte scale, means it can store thousands of terabytes. Thousand terabytes is 1 petabyte. So multiple petabyte scale columnar cloud data warehouse. Okay, what is this columnar means? All on-premises data warehouses are called, actually they are row level. Okay, all on-premises data warehouses are row level. Okay, all on-premises data were row level. But row level has some disadvantages of taking more IO and all. To overcome that, it has come up with columnar, means it will you see, we said, right, data warehouse or databases, they are relational. Relational means, yeah, database means data will be stored in rows and columns. Rows and columns means in a tabular format. In Excel sheet, how rows and columns like that. But in columnar, and the data also stored in a row wise. Okay, in Excel we will have rows, right? So row wise. But in Redshift, data will be stored in a columnar. Anyway, we'll have a separate discussion on columnar. So for now, you just know that data will be stored as a column in the database or in the warehouse, not record wise. Okay, so it's a column. All cloud data warehouses are columnar. All. Okay, Redshift, AWS Redshift, Azure, Google BigQuery, Snowflake, all are columnar because it's a known issue with row level storage. That is, it occupies a lot of IO and it is giving IO issue. So all these recently came cloud data warehouse are columnar, and it's a cloud data warehouse. Okay, and AWS is a managed service. Managed service means what? Somebody else will manage it for you. That's what I said in the first class. You don't have to worry about upgrading, scaling, patching, versioning, all these things. But on premises, if new version comes, you have to update it, the version. If some patch changes, you have to apply the patch. Okay, if you have to add more nodes, you have to add the more nodes. Everything you have to do. And if you're adding more nodes and your current server room is not sufficient, then you have to change the server room and add more nodes. And if you're adding more nodes, you have to configure physical cabling and all. So everything you need to do. That is something like self-service in our hotel. If you go to hotel, they will say, right, self-service means you should go and get the chutney and you should go and get whatever you want. But here it's managed service. Managed service means you just sit there. We will come, or no, come means nobody will come here. Okay, nobody will come to customer office. Everything will be automatically done to online only. So patching, versioning, upgrading, everything will be done automatically online from AWS site. And okay, so even adding nodes, patching, versioning, upgrading, everything will be done, and it will be done by the AWS people, not you as a customer. Okay, so some patch change. AWS generally there is a maintenance. Anyway, we will discuss all those things in the going forward. Every week there is a maintenance window. In that maintenance window, they will apply if there is a new patch, new version. Generally, server means you see Linux box will be there, and definitely software means versions will be there. Some versions will come. For example, you take our own PhonePe, Google Pay, every time there is a lot of versions, right? Even YouTube app and all, Zomato. Similarly, the softwares also will have so many versions coming in. So it will be automatically applied and managed by this AWS. Okay, so apart from that, even Redshift itself will go through a lot of versioning and upgrading with new features and all. So they also will be applied automatically. Customer don't have to worry about any of those things. That's why it is called. Okay, so in nutshell, what is Redshift? Redshift is a petabyte scale columnar cloud data warehouse. Okay, and it's a managed service. But I mean, just for your information, nobody will ask what is Redshift, because you're going for Redshift entry means they will expect that you know what is Redshift. Redshift is a petabyte scale columnar cloud data warehouse and it's a managed service. Okay, they will ask what is Redshift architecture, that they will ask. Okay, now let me tell what is Redshift architecture. Okay, actually Redshift is a cloud data warehouse. I said right. See here, right side. It's Amazon Redshift is a cloud data warehouse. And how it came into picture is, open source databases. Open source means, right? Open source means somebody creates and lays it for the world. Let them develop. Anybody can use it and anybody can customize the way that they want. That's what open source. In software, it is the common term. Open source means open for the world. People like Facebook, Amazon, Microsoft, Yahoo, Google, they will develop some project and they leave it for the public, and public can use it. Okay, and they can develop it and they can customize as they need. Similarly, this Postgres is one of the open source database. PostgreSQL. Okay, it is one of the open source database. Like we said, MySQL, Oracle, we said, right, OLTP systems. Like that, Postgres is one of the open source SQL developed by, I think Postgres is developed by, I think you can search, I think Yahoo or Google. You can type Postgres developed by. Okay, I think one person. Okay, is Postgres owned by Microsoft? When was yeah, I think one of the person, he developed it and he left for the world. Okay, so yeah, then I think everyone started using. So anyway, AWS use it means, yeah, I mean definitely if it is used, if it is developed by like Yahoo or Google, then it is a insult for them. So definitely it's not developed by Yahoo or Google or anything. Yeah, it's developed by some person. That is, yeah, we got it right. This Michael Stonebracker. Okay, so what he did is, I mean, what AWS took is, it took the PostgreSQL, and the actual Postgres is a relational database. Okay, relational database means data will be stored in rows and columns. Rows, columns. Okay, and storage will be at the row level. Entire row will be stored at the database level. So what they took is, but anyway, before going to that, I need to tell one more thing. I need to introduce you two terms, this SMP and MPP. SMP means symmetric multiprocessing. I mean, just terms you should know. Okay, what is SMP? What is MPP? SMP means symmetric multiprocessing. MPP means massively parallel processing. Okay, please remember what is SMP? Symmetric multiprocessing. Generally, single node is called SMP boss. Single node, one node will be there. that is SMP. Okay, single node is called SMP, symmetric multiprocessing. And MPP means massively parallel processing. MPP, massively parallel processing. Generally, I mean, multiple nodes is called MPP. What? Single nodes is called SMP, multiple nodes is called MPP. That's what you need to remember. What is SMP? Symmetric multiprocessing. A single node system is called SMP system. What is MPP? Massively parallel processing. Okay, or multi-node system is called MPP system. Remember what is SMP? What is MPP? Yeah, SMP means single node system. MPP means massively parallel processing or multi-node system. See here, the entire system has 4 nodes, so this is called MPP system. Okay, see here, actually these 4 nodes will be connected through cables. Yeah, generally we connect them through LAN or WAN, right? So multiple nodes will be connected. Okay, and all the data will be stored in all the nodes. And see, for example, you have only one node and all your data should be stored in that node. For example, I mean, same thing. For example, you have 100 records and you have one node and all your 100 records should be stored in that node. That is the SMP system. But if you have 100 records, you have 4 nodes. Then all your 100 records will be stored across 4 nodes. You see, across 4 nodes means each node will have 25, 25, 25, 25. That is what MPP system means. In fact, that is what distributed systems means. This is also known as distributed systems. Distributed systems means all your data will be distributed across the nodes and stored. So obviously it will have high performance. Okay, because there are 4 nodes which are receiving the data when you are loading, and similarly when you are retrieving also there are 4 nodes which are giving the data when you run a select query. So that is the advantage of distributed systems. Means data load and data retrieval will be faster because there are more nodes inside your system. So actually in single word they call it as MPP system, massively parallel processing. Okay, so earlier before MPP comes, everything was an SMP system. SMP means there is only one node, that's all. Forget about all other. Okay, there is only one node. There is only one node, and that one node only receiving all the data. Plus, one node system, how it looks like. This is only SMP system means. All your data is stored here only. Single node system is called SMP system. Bus. So how much your data it should be stored here only. That's all. So obviously it will take more time because there is only one node which is working on your data. So you see, before IT was improving or before there is not much data, so SMP systems were okay. They were able to support, but now the data is generating so much that single node systems they cannot accommodate the required speed and performance. So MPP systems came. MPP systems means multiple nodes will be there like this. You see, same nodes they will put many like this. Yeah, so multiple nodes they are called MPP system. Same thing. Okay, I mean all will be generally the same configuration. And yeah, this is called MPP system bus. So generally you need to know what is SMP. SMP means symmetric multiprocessing or single node system. MPP means massively parallel processing. Okay, or multi-node system. Okay, cool. So in SMP there is only one node will be there. In MPP, okay, multiple nodes will be there. So MPP system is also called distributed system. Okay, yeah, okay, cool. So now you know that now. Okay, now let's come back to our Redshift. So Redshift, what they did is, AWS, they took open source database like Postgres, and generally Postgres is a relational database, so it's an SMP system. SMP system means it's a single node system. Okay, so they made it into MPP system, number one. So they customized it. Okay, they made it into MPP system, and Postgres is a relational database, so it's actually row level storage. So they made it into column level storage, that is columnar, and they have introduced some new functions, okay, to improve its performance and to serve the latest business. They have added some more functions, that is OLTP functions, which are useful for reporting. So that means they completely customized it. Actually, they changed the ground level. SMP to MPP means actually architecture level changes, and row level storage to columnar storage also architecture level changes, and they have added they have added few more functionalities, that is OLAP. So the new product, they designed it as a Redshift. Yeah, that's what open source means. Okay, somebody will create it and leave it for the system, and anybody can use it, and they can customize it, and they can own it. Okay, so they have not used as it is, but they have made so many changes. Okay, they have taken the Postgres SQL, so they made it Postgres is an SMP system or single node system. They made it into MPP system, and they made from row level storage to columnar storage, and they introduced some new OLAP functions, and they designed the product called Amazon Redshift. So if anyone knows Postgres, they almost know Redshift. I mean, with respect to SQL, or of course, if you know any SQL, that's fine, because this Postgres, they are all called ANSI SQL. Any database supports ANSI SQL. So if you know any database, you are good to work with Redshift. And that if you know Postgres, at least you will know the system tables and all. I mean, dictionary tables and all much better. Okay, cool. So how Redshift came into picture? They have taken AWS taken Postgres SQL, and they have customized it, okay, by changing SMP architecture to MPP architecture, and they made from row level storage to columnar, and they have introduced some new OLAP functions, and they designed or they named that product as Amazon Redshift. Okay, so once you know like how Redshift came into picture, now we will see how Redshift will be working. I mean, this is what actually architecture means. We should tell this actually. So here we will be talking about a single node. Okay, single node. It means every node will have same setup. That's what it means. Okay, so Redshift is a MPP architecture, right? Means multiple nodes will be there. Massively parallel processing means multi-node system, or multiple nodes will be there in Redshift. So okay, then if you study about one node, same thing. All nodes the same. In every node, the same thing will be there, because all the nodes will be doing the same thing. Because if you are loading 100 records, what happening? All 100 records will be handled by all the nodes, right? So that's why every node will have the same resources and same functionality. So that if you're issuing a select statement, all the nodes will process that select. If you node insert statement, all the nodes will insert the data. If you do a select sum of something, every node will do that sum for the data that it is storing. For example, every node will have 25 records, right? If you're inserting 100 rows, then if you're giving select sum of salary, then four nodes will do sum of salary, sum of salary, sum of salary inside that node. Internally, all the nodes will do the same function. So if you study about single node, you know that all the nodes are doing the same thing. Okay, cool. So in a single node, this is what actually happens here. Okay, so in a single node, later node will be there. You see, this what we are doing is now studying about single node. Okay, so control Z, control Z, control Z. I mean, this same architecture, I just want to draw like this just to show you. So actually this, I mean, this is later node. Okay, these are all compute nodes. So in your Redshift architecture, this is all one node actually. You see, I'm talking about this is all one node. Okay. Yeah, you see, in multiple in MP, if you're talking about architecture, yes, you will have multiple nodes. Then it will become an MPP system. Okay, multiple nodes. If you talk about it's an MPP system, means multiple nodes will be there, and they are connected. Okay, but if you talk about single node, okay, so this will become later node. Wait. In compute, yeah, I think, yeah, I'm talking about the down one. Each node will have slices. Yeah, okay. So I was talking about this diagram. You talk easy. You focus on the single node. Okay, so this single node. Okay, I mean the high level diagram you already know. Okay, so multiple nodes will be there. Multiple nodes that is called MPP system. Okay, so okay, all multiple nodes will be there. Okay, then so what each node will do, that's what we need to discuss. Okay, so each node will have slices inside that node. Okay, so this is what I'm actually, yeah, this is what I'm actually trying to show it as slice, slice. Okay, yeah, like that. So it's only one node. Okay, but in that node you will have slices. You forget about this. Okay, this we are talking in single node. Yeah, in single node slices will be there. Okay, so this is a compute node. Okay, we are now talking about compute node. In compute node, what will be there? Slices will be there. That means we are talking about single node. Okay, in single node, in MPP system, multiple nodes will be there. Okay, so okay, multiple nodes will be there. They are called compute nodes. Okay, and each node will have slices. See here, slices means basically slices are, they're like computing units within the node. They will take the data and they'll process the data, they will store the data, everything, the data that is distributed to a node is handled by the slices.
Sorry, sir, to interrupt.
Okay, so
Sir, I could
yeah,
not hear you for some 2 minutes. I think in network issues, maybe. But yeah. So this is the one compute
okay.
node that you are talking about, right? One of the compute node
Yeah.
that.
Yes.
And this, what is this slice?
Yeah, slice is a computational unit within the compute node. Okay, slice is a processing unit within the compute node.
Okay, like a
Okay,
processor, like a processor. We can
yeah,
think of.
like a processor, right?
Okay, so the initial picture that you have shown, it was mentioned as compute node. So so that compute node is equal to slice here. That is what you are mentioning to the black picture that
Yeah,
you have shown.
wait.
Yeah, sorry, I missed in between, so I got confused.
No. You see, if we are talking about if you are talking about, you see, if you're talking about MPP architecture, these are all called compute nodes. Okay, compute node 1, compute node. You see here in this diagram itself, I have each one is node, right?
Yeah.
This is MPP architecture. These are all nodes. You see, within the nodes, I have showed as S1, S2. S1, S2 means slice 1, slice 2, slice 3, slice 4, slice 5, slice 6. These are all, these small boxes are called slices.
Yeah. So can you once open the AWS document that you were showing for the architecture? Black document. No, sir, the PDF file that you opened in browser.
Yeah.
Yes, sir. So here the compute node that is written. So these are so you mentioned this as a single node, and inside that there is compute node written. So I got confused here. So this compute node is separate nodes, right? Whether in this compute node there will be S1, S2 in each of the compute node, or this compute node is itself S1.
No. Compute nodes will be there. Okay, this is high level architecture. Okay, compute nodes will be there, and they are coordinated using a ladder node. Okay, this is
So
the
this
high
is a
level architecture of
this is a 3-node architecture, right? 3-node Redshift architecture in the diagram, right? Okay, got it.
Yeah. We don't say 3-node, 2-node or like that. Yeah, generally we'll put some nodes. Okay, 2, 3, 4. I mean, just to explain. But you can have any number of nodes. Okay. I mean, why I'm saying is that we should not say it's a 3-node, 2-node like that in the interview. Okay, so you just take some 2 nodes, 3 nodes just to explain him. Like that, you can have any number of nodes in your Redshift. Okay, so there is no limit. You can have any number of nodes as per your requirement. Okay, but just to show you, we'll just draw some 3 nodes or some 4 nodes. Okay. Yeah, this is MPP architecture. Means multiple nodes will be there. They are called compute nodes, and they will be coordinated using a ladder node. This is one okay, high level architecture. But how each compute node will work is what we are going to explain you in the other diagram. Yeah. So each you see, now we should also know what compute node will do, right? So see, each compute node will have slices within it.
Okay.
Slice. Slice. Okay. Each compute node will have what? Slice within it. Okay. So what is slice? Actually, slice is like a processor. Okay. So it only will do all the data operations within that compute node, because each node will be allocated some data, right? Okay. So all the data will be managed by the slices within the node. Okay.
Yes, sir. Yes.
Okay. So you see,
data is in S3, right? Below there is some database sign that is there in the diagram. So this is S3 or?
Yeah, that is S3 only. Just forget about it. Okay. Let us not talk about that disks. Okay. That is S3 only. But yeah, let's not talk about it. Okay. So right now we should say that every node will have slices within it, and those slices are responsible for processing the data that is that comes to the node. Okay. For example, if a Redshift has some 10 nodes, okay, And 10 node means here, node means compute node. Okay, if Redshift has 10 nodes, and each node will have some slices. Okay, so the number of slices will depend on what type of node you are using. We also will talk about different types of nodes in Redshift. So in Redshift we have different nodes like DS2 or DC2, RE3, XL plus RE3, 4X, RE3, 16X, like that. So based on what type of node you will have 2 slices, 4 slices, 8 slices, 16 slices, like that. So okay, so for example here you take, you see this architecture is a 2 slice, each node has 2 slices, you see S1, S2, S3, S4, like that. Okay, so for example if you talk about DC2, forget about, don't worry about node types, we will discuss, that is a separate concept. If you take DC2 node type, okay, so 2 slices will be there in every node. Similarly, node 1 has 2 slices, node 2 will have 2 slices, and node 3 will have 2 slices, node 4 will have 2 slices. These small boxes are slices I represented. If we have something like RE3 XL plus or RE3 16X, it will have 16 slices, S1, S2, S3, S4, like that, 16 slices in single node. Okay, so how many slices you will have in a node? It depends on what type of node type you are using for your Redshift configuration. If you are a big customer, you will go with costly node. Costly node means high-end configuration. Okay, so if you are like small and medium-sized customer, you will go with a medium or small configuration, which can sufficient for your business. So based on the node type, you will have 2 slices or 4 slices, like that, per node. Okay, so here my point is, this is a this compute node 1 is there, right? This is what I'm explaining. Each compute node will have slices. Here node slices, each compute node will have slices within it. Okay, so each node, okay, generally the money that how much amount we pay, that we will get node type like that. If you get small size nodes, okay, you will get some $0.25 per hour. Okay, if you want some medium type or something like $1 per hour, like that. Okay, AWS has some price category to different nodes. Okay, so at the time of creating a cluster, you will decide what type of node you want to create your cluster. So then at that time, all these slices within that node will use that memory. Okay, whatever memory this node has, that memory will be used by these slices to do any data processing. Okay, so now yeah, so yes,
Sir,
yeah, tell me.
sir, these nodes are connected to diagram show like a JDBC, ODBC. ODBC, JDBC means, sir?
They are the drivers. For example, server will be somewhere, right? Where is the server? Server is there at the AWS data center, right? Yeah, but customers are doing business all over the world. So how do they connect to server? Through drivers. That is only JDBC. Okay. So if you want to access Oracle or anything, you will have some client software, right? That is only JDBC, ODBC. See here, client application. Customers are all over the world, but how can they connect to the server? So they need
Yes, sir.
drivers. We need drivers, right, to connect.
Okay, sir.
Yeah, that is called JDBC, ODBC drivers.
Any abbreviation, sir? JDBC, ODBC?
Yeah, Java database connectivity, and ODBC. I think open, or just let me say. J means I know Java database connectivity. ODBC means I think Open Database Connect, the Microsoft Open Database Connectivity. Okay, so these drivers are required to connect to the server. Generally, we as the client we use it. Okay, I think it is open database connectivity. Similarly, JDBC means, yeah, these are all drivers actually. Java database connectivity. See here, that allows Java programs to access the database management system. So if you want to connect any database, we need either JDBC or ODBC. But nowadays, yeah, mostly people are using JDBC. But any database will release both the drivers. Okay, because some people will use ODBC, some people will use JDBC. Okay, so is the ODBC is designed using C programming. Okay, C programming language. That is used to access the database management system.
Yes.
Yeah. So yeah. So my point here is we are talking about a compute node, and each node will have slices. Okay. So actually, the slice is the one which will work on the data operations. So now let us study like what is there in this slide. Ladder node. What is this ladder node will have? It will actually coordinate all the activities of all the compute nodes. Okay, when you configure a system, you will get the ladder node free. Okay, you will not be charged for a ladder node. You configure for 2-node Redshift cluster means you will get ladder node free. Even you configure 5-node, 10-node, any nodes, you will get ladder node free. Ladder node is it's like ladder. Okay, it will coordinate all the activities of the compute nodes. Okay, ladder node don't do any data storage and all. It will only, you see here, it will act as a communication between all the compute nodes and at the customers or client applications. It will take the requests and give to the compute nodes, and it will take the data from compute nodes and give to the clients. Okay, so and of course metadata means the DDLs and all. It will have complete idea about what type of tables are there and where they are stored, everything. It will have all the idea. So ladder node stores metadata, manages communication with client programs and compute nodes, manages distributing data to slices on compute nodes, develop and distributes execution plan for compute nodes. Yeah, basically it will distribute the data to all the compute nodes, because we said right, data will be distributed to all the nodes. But now you should know that when you say node, but data is actually being distributed to slices. Because what node will have? Node will have slices. So when ladder node is distributing data to compute node means actually it is being stored in the slice within the node. Is that point clear?
Yes, sir.
So can you once repeat the last statement? In the nodes it will be stored.
Yeah, when we say data is distributed to node means where exactly data is stored? Slices within the node. Slices.
Okay, so it will be stored by default, or when we will be querying or doing work, then only it will be stored.
No, it will be taken care by the Redshift. We don't do anything. We don't do anything. We are only knowing how the Redshift will function. Okay, we don't do anything. When we load the data will automatically distribute it to the slices. Is it SLICES slice? Okay, so where the data is stored? Within the node. But within the node, where exactly it is stored?
Slices.
Within the slices. Are you clear, Somnath?
Yeah, I'm clear, sir, but I am not able to understand one thing. Like the data is stored, like it will be permanently stored in the slices after the load gets over, or like we are doing day-to-day 1 TB, 2 TB transactions, right? But in the node EC2 will have very less capacity. So how that much data will be stored, or how then it will increase lot of compute.
Don't worry about it. Right now you understand that all the data will go to node, but actually it will go to the disks. So don't have to worry about its capacity. It will go to disks only. But how it will go? It will go through slices. Slices are only connected to disks. Okay. But giving to disks and retrieving from disks will be done by the slices only. Slices only will have that connectivity, because you will get terabytes of data. How can a slice will store terabytes of data? It has to finally go to hard disk only. What is that hard disk? That is S3. But that will be done by the slices only. So while explaining, we will say that data will go to slices. But actually, what slices will do? It will go to underlying S3s or disks. You got it?
Yes.
Yeah. So when we say, but any operations that we do, like, inserts, updates, deletes, segregation, sum, average, min, max, so they all will be done by the slice only. Now you're clear? Compute node will do, but actually compute node, within compute node, what will do? Slice only. We see, for example, we are eating food, right? We are eating food. Yeah, I ate biryani, but who ate biryani? I ate biryani, but who digested? I digested, but who is that within me digested? My stomach got digested, right? My stomach only digested, right? But I'm saying I digested. But within me, my stomach is there, it digested. Similarly, when compute node stored means what exactly within compute node means? Slices, the one who will be processing the data. You understand, Somnath, now?
Yes.
Yeah. So we don't clearly say my stomach digested or something like that, or my legs walked, or my hands did. We don't say like that. I did. I digested. I walked, I say. Similarly, we say that compute node stores all the data. But who exactly within the compute node will stores? Slices. Because when you study science, then they will go in detail. Okay, human body digests, but which what is the body part that is called, which is used for digestion? Then the answer is, what is that? Digestion system. I mean something. So that stomach or digestion system we will refer. Similarly, within the digestion system, which one? What is that? Chinna pegulu, pedda pegulu. So that one we will refer. Similarly, we are studying about the architecture, so we are going in detail. Which part within the compute node will do that? So we are talking about a node slice. You're clear, right, Somnath?
Yes, sir.
Yeah. So because he may ask, but generally in interview they will ask like, what is this slices and all. That's why I'm just touching you. Okay, yeah, definitely they will ask. In fact, definitely you should also tell while answering the architecture. Okay, and Redshift we have ladder node. Ladder node will act as a communication channel between client applications and compute nodes, and it will only coordinate, and it gives the data to compute nodes, and it retrieves the data from the compute nodes. Okay, so, and of course it manages, distributes data to slices on the compute nodes, develops and distributes the execution plan to compute nodes. Yeah, it basically distributes the data and yeah, execution plan to compute nodes. That's all about ladder node. Compute nodes actually execute the query segments in parallel and send the result back to the ladder node for final aggregation. Yeah. So for example, if you give select sum of salary, then all the compute nodes will do sum of salary, the data that they have, and they give to the ladder node. Ladder node will merge all the data and will give to the customers. Okay, so that's what each second point, each compute node, I see, execute the query segments in parallel and send result back to the ladder node for final aggregation. Yeah. So whatever data given by the compute nodes will be merged and sent to the client applications by the compute. Then each compute node has its own dedicated CPU, memory, and attached disk storage. You see here, every compute node will have, it comes with some memory, okay, some CPU, some storage. So that's why they because otherwise how can they process the data? So every compute node will have some CPU, memory, and storage. Okay, and that CPU, that memory, that storage is used by the slices. Those slices, you see, Now, what is node slice? Slice is allocated a portion of the node's memory and disk space. This slice works in parallel to complete the operation. Say second point. Actually, the slice is the one which will do the activity. What is that activity? All the data processing operation, inserts, updates, deletes, aggregates, select sum. Then all the sum, everything will be done by the slices. And where from the slices will have memory, storage, and all? Because node will have memory, right? That node's memory, CPU, disk space, that only will be used by the slices. How our stomach will get energy from the body? In our body we have blood and all, right? So from the body only stomach will get energy and it will digest the food. Same thing, slices will use the whatever the disk space, memory, CPU is assigned to that compute node, that will be used it for the data processing. So the number of slices per node is determined by the node size. Yeah, I said, right, each node will come up with particular number of slices. So some slices will have two, I mean some nodes will have 2 slices, some nodes will have 4 slices, so some nodes will have 16 slices. Okay, so based on what node customer is using to create Redshift cluster, number of node slices will change. Don't worry, that we will see when we create a cluster. If you create, for example, DC2 cluster, you will have 2 slices. If you create RA3XL 4XL plus cluster, you will have 4 slices. If you create RA316X cluster, you will have 16 slices. So like that. So based on which node type you are using to create your cluster, you will have that many number of slices. Okay. So all the slices will make use of, and you see every node will comes with particular CPU, memory, and disk space. So all these slices will use their nodes resources to do all the data operations. Are you clear about what is slice, what is compute node, what is ladder node, what is SMP, what is MPP?
Yes, sir.
Yes.
Okay, so yeah, I don't want to proceed further anyway, time is also over. Just study about it. Tomorrow again I will revision this. Okay, yeah, very important to get clarity on what is ladder node, what is compute node, what is slices. I mean, because this is one of the standard question and mandatory question they will ask in the interview. Compulsorily it will be asked, no doubt about it. Okay, so tomorrow also I will do the revision. You also go and read about it. Just type in Google, I mean Redshift architecture, you will get it, the AWS documentation. Okay, same, so this slide is from there only. Everything that I showing is available in the documentation, don't worry. See here, same diagram, docs.aws.amazon.com, you open and from there you study. Okay, here also it explains about ladder node, compute node, node slices and all. See here, and if you have more doubts, you just ask me tomorrow. Okay.
Yes.
Okay, cool. So then yeah, I don't want to answer any questions today because I know maybe some, or let me know, do you have any questions?
So what type of questions specifically they will ask for architecture, except from do you know the architecture or not?
Yeah, can you please explain Redshift architecture? That is the way they will ask. Can you please tell me Redshift architecture? Then as you answer that question, they may ask like what is compute node, what is ladder node. I mean, generally before he asks only, in your answer only, you will tell everything. That is the right way of answering. Don't give him the chance to ask another question on the same thing. You should only tell what is, I mean, while telling the architecture, you should tell, okay, about ladder node, about compute node, about slices. Then, okay, yes, this guy has all the knowledge. Otherwise, he will ask, I mean, if you don't say, definitely he will ask what is compute node, what is node slice, all this stuff. That means you're not telling, so he's asking. But if you tell, he don't say, he will go to next question. Okay. Yeah, the question is, what is the, can you please tell me about Redshift architecture? That is the question will come, and it's a mandatory question that will come. Okay.
Yes,
Yeah,
sir.
and then okay then, see you tomorrow. Study and come. Okay, tomorrow also once I revision it and go to the next topic.
Yes.
Okay then. See you tomorrow.